students, I'm Aanchal Sharma, your educator. In this video, we are going to discuss few concepts that are related to global warming. We are going to discuss about the global warming potential, and we are also going to discuss about ozone layer. Few things that are always asked in your paper. So, we are going to discuss first of all about the greenhouse effect. So, the term greenhouse has been derived from the phenomena that occurs in a greenhouse, and we all know that. In a greenhouse, the glass panel lets the light in and does not let the heat go out and to escape. Therefore, the greenhouse warms up very much like inside of a car that has been parked in the sun for a few hours. Right, so it becomes too hot and it does not let the heat to escape and the light can pass because it is made up of the glass panel. So the same concept is being used for the explanation of the environmental effect that happens, and we call it again as greenhouse effect. So the greenhouse effect is a naturally occurring phenomena that is responsible for heating of the Earth's surface and atmosphere. The sunlight warms the surface of the earth. Since the earth cannot store this heat forever, the warm earth sends the energy back to the space. But now what is happening? Because of so much anthropogenic activities, the greenhouse gases that are present in the earth are increasing so much that more and more amount of energy is trapped. This more and more amount of energy is now entering the surface of the earth, and because of this the earth is becoming too hot. Also, it is the 90% of this heat is absorbed by the water bodies, and because of this the water expansion, or you can say the thermal expansion of the water, is also occurring. So there are a lot of problems that are caused because of the increase of the greenhouse gases. The sunlight which hits the earth's surface is made up of high energy ultraviolet and visible radiation, and we call it as UV rays, and this was a question in the exam as well. The energy emitted from the surface of the earth is the infrared or the long wave radiation and is less energetic than the sun. This is also important. Now, you can look at this picture. The Earth's greenhouse effect occurs in this manner. The surface cools by radiating the heat, and then the heat energy above, the warmer surface and greater amount of heat energy that is radiated upward. Right, so there is sun, and about half of the solar energy is absorbed by the surface of the water, adding most important greenhouse gases to the atmosphere. When this water condenses in the atmosphere, it releases the energy, and then you can see some of the energy is trapped in the earth's surface while some is bounced back. Right, so these are the ultraviolet rays, the UV radiations. About 30% of the incoming solar energy is reflected by the surface of the atmosphere because of the presence of the greenhouse gases. Only a small amount of heat energy emitted from the surface passes through the atmosphere, and mostly it is absorbed by the greenhouse gas molecules that are present. It contributes to the energy radiated back down to warm the surface and lower the temperature. This whole is the phenomena of what happens in the space when the ultraviolet rays falls on the surface of the earth. So the particles and the gases in the air absorb the infrared heat radiation, and the gases are called as the greenhouse gases. These gases that are there for the absorption are called as the greenhouse gases. They let the sunlight in and they do not let the heat radiation from the earth to bounce back in the atmosphere, because we need to protect the temperature of the earth also. We need to maintain the temperature. They trap the heat near the ground. So the greenhouse effect is very important for the life of the earth. The average temperature of the earth is about 15 degrees Celsius, and if there is no greenhouse gases, the average temperature would be about 30 degrees Celsius lower. So that is why it is very important that we maintain the temperature, and for maintenance of the temperature we need to absorb the sunlight here, so that the energy here, and for the absorption we need the greenhouse gases. But if the greenhouse gases would increase, then what will happen? More and more amount of heat would be captured. The earth would become more and more hotter, and because of this you see so many different problems that can occur. And it is what? It is the atmosphere that protects the harmful ultraviolet rays to enter to the Earth's surface. Here we have the stratosphere. Atmosphere is divided into different layers, and we have done this in the class as well. So stratosphere ke andar we have ozone, and this ozone is something that protects the Earth's ultraviolet rays, that is the harmful rays, to come and get, to affect the people living in the world, right? Because skin cancer and other problems are caused if ultraviolet rays can enter the Earth's surface. So we need to protect the ozone layer. So these are few things that you should remember, right? So we need the natural greenhouse effect, but by putting more and more greenhouse gases into the air, humans have enhanced the natural greenhouse effect, making the Earth too much warm. So all the anthropogenic activities are now causing a lot of problem. And it's not the natural greenhouse effect that is causing the global warming. It's the additional amount of greenhouse gases that are the main culprit. So we are emitting a lot of greenhouse gases like carbon dioxide, because of which we are causing problem to the Earth's surface. The greenhouse gases warm the Earth by absorbing the energy, and they slow down the rate at which energy escapes the space. So as I told you, some of the energy bounces back. So what happens when there are a lot of greenhouse gases, the concentration of greenhouse gases increases, then the energy escapes very slowly. They act like a blanket here to protect the Earth's surface. Different greenhouse gases can have different and varied effect on the Earth's warming. Two key ways of how we actually calculate that which gas is more harmful and which is less harmful is what we see. Key ways in which these gases differ from one another are what? Each other are the ability to absorb the energy. What is their ability to absorb energy? This is called as the radiative efficacy, efficiency, and then how long they can stay in the atmosphere. This is called as the lifetime. So how much energy can they absorb and for how long they can be present in the atmosphere. These are the two criteria, and by these combining, the net effect of these two ideas or these two ways would give us what? Will give us the global warming potential. So the global warming potential of a greenhouse gas is calculated on the basis of these two criteria. First, the ability to absorb energy and how long they can stay in the atmosphere. The primary greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, and then we have ozone. So other greenhouse gases are carbon monoxide, we have fluorinated gases, we have the chlorofluorocarbons, we have black carbon, then we have the brown carbon. Along with the greenhouse gases, only water vapor can absorb both incoming UV and outgoing infrared radiation, right? So this is only the water vapors are something that can absorb the incoming and the outgoing vapors, outgoing rays that are present. So this is the effect. The natural greenhouse effect is something like this. Here the sun will radiate, these are the solar radiation, this is the atmosphere. We have some re-radiated heat that goes on, and this is the less in amount because it's a natural effect that goes here. But what is happening now? More and more of re-emission of heat is happening. Why? Because the concentration of the greenhouse gases are increasing. The concentration of the carbon dioxide, methane are increasing. Because of this, the effect is becoming too much, right? And the Earth is becoming more and more warmer. The global warming potential now. So the global warming potential, GWP, depends on both the efficiency of the molecule as the greenhouse gas and the atmospheric lifetime. The GWP is measured in the relative. From which do you compare it? From the which gas you are comparing it? We compare it from the carbon dioxide gas. So relative, we measure it to the mass of carbon dioxide and equated for the specific time scale. So we measure it on the relative manner of the same as the carbon dioxide. Thus, if the gas has a high, that means the positive radiative forcing, but also a short lifetime, it will have a larger global warming potential on a 2-year scale, but a small one on a 100-year scale. So we have two scales also. We will see on the basis of which scale we have the more positive radiative force, right? So we will see on the basis of how much energy can be calculated, can be absorbed, and how much long time can the gas be present, for how long the gas can be present. So atmospheric lifetime and the efficiency of the molecule is calculated, and also on the basis of 2 years, we see it on the 20-year scale, and we see it on the 100-year scale also, right? So if the molecule has a longer atmospheric lifetime than carbon dioxide, its global warming potential will increase when the time scale is considered, right? So we take base as the carbon dioxide. So carbon dioxide is defined to have the GWP of 1 overall in all the time periods. Some gases like methane have a larger global warming potential, since a ton of methane absorbs much more heat than a ton of carbon dioxide. So when we compare the different gases, we will take the base year as carbon dioxide. Methane is one gas, and there are other gases also that are more harmful. Why? Because they can absorb a larger amount of energy, right? So some gases like methane have a larger global warming potential, since the ton of methane will absorb more heat than what a ton of carbon dioxide can do. Methane has an atmospheric lifetime of about 12 years and from about 3 to 12 years, and there was an analysis that was done in 2014 which states that although methane's initial impact is about 100 times greater than carbon dioxide because of the shorter atmospheric lifetime, but 6 and 7 decades, and if you see impacts on these two gases, the impact of the two gases is equal. If you increase the lifetime, then the impact of carbon dioxide and methane can be equal, and from then on methane's relative role continues to decline, right? So we have said that yes, the role of methane is declining if you take the time span, if you increase the time span. So this is one thing, diagram that you can note, or you can say this table. This table in front of you shows the different GWPs. So you see that carbon dioxide is given the maximum amount of, is given the first value because we are comparing everything to it. Then we have methane, then we have nitrous oxide, then we have chlorofluorocarbons, then we have hydrofluorocarbons, hexafluoromethane, etc. And the lifetime is given on the basis of 20 year, 100 year, and on the basis of 500 year. These are the few gases that can cause problem. So methane is estimated to have a global warming potential of about 28 to 36 over 100 years, and methane emitted today lasts about a decade on an average, which is much less than carbon dioxide. But your methane also absorbs more energy than carbon dioxide. These are the few things that you should remember. The net effect of the shorter lifetime and higher energy absorption is ultimately reflected on the global warming potential. The methane global warming potential also amounts for some indirect effects that happen in the atmosphere, right? Let us move forward. Now let us study about the ozone layer and the depletion of the ozone layer. So ozone and its occurrence. So what is ozone? Ozone is basically a gas that is very much pale in color. So it is a pale blue in color, odorless gas, and it is odorless, and it is composed of 3 atoms of oxygen. So the formula is O3. Mainly present in the stratosphere and in the form of a thick sheet. So we have we all know what is atmosphere. So atmosphere is a thick layer of gases that prevent us from the ultraviolet rays, the UV radiations of the from the sun, right? So what is happening? We have ozone that protects us from the ultraviolet rays, but the presence of ozone is depleting day by day because of the anthropogenic activities and other reasons, right? This thick sheet is called as the ozosphere. The thickness of the ozone layer differs as per season and geography as well. Now, what are the causes of the depletion? The main cause for the depletion of the ozone is determined as the excessive release of chlorine and bromine from the various man-made compounds like the chlorofluorocarbons. So, because of the presence of chlorine and bromine, the oxygen molecule, or the, you can say, the ozone molecule will be will keep on breaking, and ultimately we see that the ozone is depleting, right? So these man-made compounds are found to have a direct impact on the depletion of the ozone layer. These are categorized as the ozone depleting substances, right? So we have studied about the Montreal Protocol and Vienna Protocol. These are the protocols that are talking about the protection of the ozone layer and how we need to use less and less amount of ozone depleting substances. So chlorofluorocarbons. So this is the most extensive and utilized oxygen depleting substance because it attributes to more than 80% of the overall oxygen ozone depletion. So ozone depletion का सबसे ज़्यादा किस molecule gas से ozone depletion होता है? So it is none other than your CFCs. CFCs, which stands for the chlorofluorocarbons, cause about 80% of the ozone to get depleted. That is why it is advised not to use it. It is utilized as a coolant in the home appliances like refrigerators, or you find it in the freezers or air conditioners, both in buildings as well as in cars. So this can cause a lot of problems. Hence, we need to minimize the use of the chlorofluorocarbons. Then we have the hydrofluorocarbons. The hydrofluorocarbons have over the years served in place of, it was first of all used in place of the hydrofluorocarbons, but they are also very harmful. So we need to limit the usage of the hydrofluorocarbons also. And the Kigali Agreement, all of these agreements talk about the hydrofluorocarbons. They are not as harmful as the chlorofluorocarbons to the ozone layer, but they are harmful as well. Then we have halogens. It is essentially used for it is essentially used in the fire extinguishers, but it also creates a lot of problems and it has a devastating effect as they can again minimize the ozone layer. Then we have carbon terachloride. It is also selectively used in the fire extinguisher and as solvents. We have methyl chloroform, which is also used in the cold cleaning and also vapor decreasing and other chemical processes, and this can also cause problem. Now, formation of ozone. So ozone is basically formed naturally in the upper stratosphere. So when the wavelengths less than your 240 nm are absorbed naturally and these molecules are dissolved, it will give you the O atom. This oxygen atom is then combined with the O atom that is given is combined with the oxygen molecule to produce your ozone that is present in the stratosphere. In the stratosphere, about 19 to 30 kilometer above the Earth's surface, ozone is constantly being produced and then it is destroyed naturally. So the ultraviolet rays would fall there. The ozone would would have the power to absorb the ultraviolet rays. Some would die, some would fall apart, and some would again be produced. So this is a natural process that keeps on going. This production and this destruction makes the stratosphere, which the ozone layer that filters the ultraviolet radiation from the sun and protects the life on the earth. Normally, there are fine balance between the production and the destruction, but because of the anthropogenic activities, now the production is decreasing. Because of this, we see ozone hole, and because of this ozone hole, the UV rays can enter the Earth's surface and can cause a lot of problems like skin cancer. So this is the reaction that is present in front of you. Now let us study about the depletion of the ozone layer. So the maximum amount of depletion is done by the chlorine and the bromine molecules that are present. Chlorine being the catalyst because of which the depletion of the ozone layer occurs, right? So this formula in front of you shows how chlorine reacts with ozone and makes ClO, and every time the ClO will combine with the oxygen, combine with the O3, that is our ozone, and the depletion of the ozone occurs, right? So the man-made chemicals such as the chlorofluorocarbons are used in various places like the aerosol sprays, like refrigerator, coolants, etc. And they all destroy the ozone molecules that are present in the stratosphere. The CFCs themselves do not destroy the molecule, but they decay the ozone molecule at the low temperatures. So these CFCs are not directly depleting, but at the low temperature, the chemical reactions occur and the chlorines are made, the free compounds of chlorine are made, because of which the ozone is depleting. A small amount of chlorine atom and chlorine monoxide functions as catalyst in the process of destruction, and this is the equation right in front of you, which says that yes, the O3 is again and again depleting. So the chlorine atom in the above reaction functions as a catalyst and not as a reaction here, and not as someone that can be consumed. Chlorine atom used in the reaction remains as chlorine atom even at the end of the reaction. Once the chlorine has broken one ozone molecule, it is free to repeat the process again and again. The chlorofluorocarbons are very stable and they can live up to 100 years in the atmosphere, because of which they will again and again produce chlorine, and these free molecules of chlorine and your chlorine monoxide act as catalyst and will break down the ozone layer. Now what is the unit of calculating the ozone layer? So we have Dobson. Dobson is the unit. It is itself a PYQ. They have asked it before. Dobson unit, which is denoted as DU, is the unit to measure the total amount of ozone in the atmosphere above a point on the Earth's surface. One Dobson unit being equivalent to the layer of pure ozone is what? It is 0.01 mm thickness. It is a standard measure that has been it is a standard way that has been made, right, at the standard temperature and at a standard pressure. So Dobson unit, DU, you need to remember this, and the pure thickness of ozone layer. Both of these have been asked in the paper. So this is a PYQ and this is a PYQ also. They have asked about the greenhouse gases, that is the PYQ also, and global warming potential is also asked in the paper. So harmful effects of the ozone layer depletion, and let us study about this. So ozone layer protects all life forms on the Earth from the sun's harmful UV radiation. Any significant decrease in the amount of ozone in the stratosphere will do what? Will let the UV rays enter the Earth's surface, which can lead to a lot of problems like ill effects on the human health, the vegetation, also marine life can have problems. Then we can have different effects on animals. Animals can also suffer, and the materials can also suffer. Other materials that are present can also get eroded because of the UV radiations. Now we have studied some of these concepts that are very important from the exam point of view. Let us now see different questions pertaining to those topics only. So given below are the two statements. We have reason and assertion. Large scale dams also cause the greenhouse gas emissions. When submerged vegetation decays, it produces the carbon dioxide, which is a greenhouse gas. So do you think the reason is correct and the assertion is correct? So A is the right answer, that yes, both assertion and reason are correct. When the large dams are made, the whole process emits a lot of carbon dioxide and methane as well. And when submerged, even the vegetation also decays and can cause a lot of carbon dioxide to be released. Ultimately, carbon dioxide is a greenhouse gas. So, both the statements are very much true. Then global warming is attributed to the presence of the following gas in the atmosphere: methane, sulfur dioxide, surface ozone, then we have nitrogen dioxide and carbon dioxide. Which of these gases are ultimately problematic and can be termed as the gases that are causing global warming? That is, they are heating melting the water that is present in the glaciers, or they are also causing other problems. So because of the global warming, the problems are caused. Now what are these gases? So second is the right answer. That means A, C and E are responsible for global warming. These are the gases that are letting the UV rays enter the earth. These are the gases that are causing global warming. The temperature of the earth is increasing. We have A, C and E as the right answer. A, C and E, that means methane, C, surface ozone, and then we have carbon dioxide. Then over the past 100 years, the estimated rise of the global sea level is by 10 to 25 centimeter or more. Which of the following is the maximum contribution to it? Which has done the maximum contribution? We have the thermal expansion of the water bodies or the ocean waters. We have glacier and the ice cap melting. Then we have Greenland, or you can say that we have the Greenland ice sheets that are thinning, and we have the terrestrial water storage that changes that are happening because of the human activities. So what is the one cause that is causing a lot of the sea level to change? So the right answer is thermal expansion. Now as the earth is becoming hot and as the gases enter, so it is mostly all the heat that is present in the atmosphere. About 90% of this heat is absorbed by the water bodies. As the water bodies absorb the heat, so this is the water body, these are the water molecules that are present. As the heat is absorbed, so what happens? The water expands. So as the water expands, we see that the global sea level is also rising. So this can also cause multiple problems like overflowing of the rivers or the seas, and can cause floods, etc. So this is how the problems can occur, right? So whenever there is the global warming, and what is global warming? Excess warming of the earth's surface because of the different gases that are present, right? Because of this, the sea level is also rising. Now they have also asked this one question, that do you feel that the sea level rises equally everywhere? So the answer is no, because it rises according to the temperature, according to the terrestrial conditions, right? So the answer to this is no. Now I believe this is the last question for you. Halocarbons contribute significantly to global warming. Halocarbons also catalytically destroy the stratospheric ozone. These are the two statements. Now what is the right answer? The right answer is A, that both the statements are true. So chlorine and bromine are made up of these hydrocarbons. Because of these hydrocarbons, significantly the global warming is done. Also they act as a catalyst because chlorine and bromine are made and they live in the atmosphere, and as we see the reaction that I was telling you, ozone will again and again break and the depletion of the ozone layer would happen. So these are the few things that I wanted to discuss. We have discussed them in greater detail in the class as well. I hope you understood. If you have any doubt, you can write it in the comment section. From just this video, you must be clear now that there can be 3 to 5 questions just from this single video. So read the environment topic very clearly and just read the notes again before you just go to give your paper, right? So I hope you understood. If you have any doubt, you can write it in the comment section. I'll reply to you. Thank you so much.